Howdy! On this video, I'm going to be solving the second question of homework number 4. The first thing that we need to do is to read the question. In the instruction, it says that we need a header, and we're going to be writing a Python program for the Taylor series of the exponential. The user should provide the number of iterations and the value of x. Then you will use the examples covered during class, and we will code using loops. And then it says how you need to name the file, and that you should use the building function from the math library to compare your answer. And there is an example of how uh, the possible solution could look like. So and also it says that you don't need a function. You can have a function you want, uh, um, but I'm going to just be doing it in the main. So the first thing that I'm going to do is that I know that I need to ask the numbers of iterations from the user and the value of x from the user. So number of iterations, I'm going to call that a stopping point, and the stopping point is equals to the integer from the input that says enter the number of terms in the approximation. Okay, so we're going to get the stopping point from there. And then we need to get the value of x. So x is going to be equals to whatever the user wants. Enter the value of x. So line 9 and line 10 is going to get the inputs from the users that we need to solve this question. And then because now we have the inputs, now we can start using the formula. And the formula for the exponential is this one. Let me zoom in. The summation from 0 to positive infinity of x to the n power over factorial of n. Oh, here I have a grammar error, which is very common for me. So I know that I need a loop, and then I'm going to be using a for loop. So for I in range of a stopping point, colon, and then here, because of the formula, we know that we need to have a variable that's going to be holding the summation for each iteration. And that means that I need to have over here result equals to 0. And then I'm going to, and result has to be outside of the for loop. So then over here, I know I'm going to create temporary variable, which is going to be the formula. And you need to use your parentheses to help you transfer the formula from paper into your code. So the first thing that I'm doing is to have parentheses, because I know that there is something over the division and something under the division. And I know that over here is x to the n, and luckily x is the same x that we have here, because we name the enter the value of x is storing our x variable. And that is to the n power. But here in my for loop, I said that it is I, which is this I specifically. I'm just making things bigger. And of course, you can change this to n, and you can put it just like in the formula, x to the n power over n, but we need the factorial. So I'm going to use from math import everything, and then over here I have the factorial. So now I have the formula in Python code. So x to the n power over factorial of n. And then we need to add it to keep track every iteration. So line 13 is going to calculate the result at that specific iteration, but then the result is actually the summation of every iteration. So it has to be sum equals, not sum, result equals to result plus TMP to the temporary variable, and that should be able to calculate my exponential. Then over here I need, let me see the instructions. So over here I'm going to print my information. I'm going to print my data. So print from my homemade exponential function value of e to the x is something, and that something is going to be result. And then I need another one, the value of e to the x from Python math library is something, and that something is exp to the x from that we got from the user. Now I think that it is done. So now I'm going to run the code, approximation 100, and x is 5. And here we can see that my answer is 148.4131, and the answer from the math library is 148.4131. So it is done. Let me check. Let me read the instructions to make sure that it is everything that we need. Yeah, I think that it is good to test your code in multiple cases. So now let's say approximation 100 again, but now let's say x equals 5, and yeah, it is working. So let me know if you have questions, and this is only one way of doing it. There are multiple ways of answering this question, but I hope that you were able to learn from this example. um, well, we did not encounter a big bug on this code, so that is good.